Hello everyone, back tuning into today's video. Well, here we go, we're at the start of September, nights are drawing in, and it's time to start thinking at Gazwavids about becoming winter. As always, at the start of September, we begin our winter updates. Now, of course, we've already done the first sort of stepping stone of the winter updates, which was the NAO forecast. We released that at the start of July, and that, I'll just give a quick recap of that. It predicted that we're likely to have near neutral NAO set up in the Atlantic this year, which means the Atlantic shouldn't be as big a driver for this winter as it has been in the past few winters when it's been set up for a very positive NAO, North Atlantic oscillation. So that was our first step, but now it's time to start building upon that. So we're going to start doing the winter updates every week at Gazwavids. This is going to be something like 10 winter updates and 3 seasonal model updates, then the final forecast at the beginning of December. So we're in for a long season of updates and analysis and information. I know a lot of you enjoy the journey that we take to get to the winter. We begin it at the start of September. And even if the destination isn't all that exciting when we finally release the forecast at the start of September, start of December, I know that a lot of you do enjoy the winter updates and the journey that we take. So I'll get on with that in a second. Before I get on with that, just say about the ads. There's links to articles on all the pages. Have a browse widgets and click through the links. If there's any articles that you're interested in, you'll be helping us to pay for our website. Thanks very much for doing that. There's also video ads on most of the pages, which overlap content. When you watch them, they close back up again. It does all help to pay for Gazwavids.com. Going to be quite a long video, so you can't watch it all in one sitting. Don't worry, it's going to be kept at website on the winter updates page indefinitely, so you'll be able to come back whenever you want and watch it. There's also going to be a written version later on when it's added to winter updates page. At the moment, you're probably watching this on the home page, but later on this afternoon, it will be added to winter updates page with a written post just saying what we've discussed in the video for anybody that can't watch the video. I've got a bit of a tickle in my throat at the moment, so I've got my trusty glass of water with me. I may have to stop and pause the video and have a quick sip of water and let my vocal cords rest, so hopefully you won't notice any joins in the transmission. Right, let's get on with it then, and we'll start with where we began with the NAO forecast. So this is the sea surface temperature anomaly map from the middle of May this year, and just to recap on that NAO forecast, we've had this cool water up here, but we've got a fairly warm tropical Atlantic, and we said that although it wasn't set up, the Atlantic Ocean, for a traditional positive North Atlantic oscillation, it also wasn't set up for a traditional negative North Atlantic oscillation. It looked quite neutral, I think. So we're probably going to be on the positive side of neutral. But I'm not expecting the Atlantic to be quite as big a player this year as it has been for the last 3. Because we have 3 very mild winters. We have the last cold winter was 2012, 2013. 2013, 2014 was exceptionally wet and very mild. 2014, 2015 was mild, not as wet, but generally quite a mild winter. And then last winter, of course, 2015, 2016, again, very mild winter, particularly so in December, where we had record-breaking warmth in December 2015. All of that driven by very positive NAOs in the North Atlantic. As I say, I'm not expecting the NAO to be quite the player this year as it has been over the past 3. So the big driver of the winter is always ENSO, what's going on in the Pacific Ocean. That's always the biggest driver, be it El Nino, we have a warm event, or be it La Nina, we have a cold event. That is always the broad main global driving weather system, if you like. And last winter, of course, we had that exceptional El Nino. It was one of the warmest El Ninos ever recorded, biggest event on record, or one of the biggest events on record. So this is 2015 just here. This is the ENSO by season map. And with this, we can go right way back to 1950, of course. I use these in the ENSO updates, this chart and this website, very useful website. So we've got got the red numbers in boxes, that's El Nino. And of course, last winter, 2015, which is just here, in 2016, we had these very positive numbers, red numbers, indicating that record-breaking El Nino event that lasted into the start of 2016, of course. Now, where we are right now is that we've gone back towards ENSO neutral. Very often after an El Nino, you get a La Nina event, for example. That happened in 2009, 2010. So we had the El Nino of 0910, which is just here. And then we went into the second half of 2010, and you notice these blue negative numbers appearing. That is the La Nina, the cold event that followed the El Nino, the La Nina of 2010, 2011. And again, you see it further back. If you go back to 1998, we have the big El Nino event of 97 and 98, which is those red numbers just there. And then in the second half of 1998, we get these negative blue numbers appearing. Again, La Nina taking us through 98 and into 99. Very long-lasting La Nina there, going right way through start of 2001. Anyway, where we are right now is that we're around ENSO neutral. So we've lost these red numbers, we've lost El Nino, we've gone towards neutral, and you would probably think that at this point we're going to start moving into blue negative numbers into a La Nina event, because that's normally what happens. However, not so, because La Nina this year is fading. This is the latest SST anomaly map from NOAA. We'll be looking at this a lot over the coming few weeks and the next couple of months as we run up towards the winter. But I'm not expecting huge changes in terms of what's happening for the Pacific anyway. From this picture. So ENSO is what's going on just here. And, of course, we've got Peru over here, we've got Indonesia over here. This is the equator. And when we get warming of the ENSO region of the equator through the Pacific Ocean, that's El Nino. When we get cooling, indicated by these blue colours, that is La Nina. Excuse me. So what we see is that we have got a little bit of blue here, but it isn't a La Nina event. There's not enough of it. It's not extensive enough. It's not cold enough to be warranted as a La Nina event. So what we've got is ENSO neutral on the slightly negative side, but we certainly don't have a La Nina event, and that is the way the modelling is tending to trend at the moment. So I'm not expecting a big change from this. I think we're going to keep this sort of very weak, borderline La Nina, but really ENSO neutral through in towards winter. Of course, we've got to analyse what that means, or what it could mean for the winter, because from El Nino to La Nina and then ENSO neutral in between, these situations in the Pacific Ocean, they have quite differing outcomes for the global weather system, particularly El Nino is a phenomenon that affects the southern oceans and the Pacific Ocean. It also affects America, because of course there's America just there right next to the Pacific Ocean, so it does have an effect on Canada and America. We're downstream from that, so it doesn't have as big an effect for us, but there is undoubtedly effects when the events get very big. So very strong El Ninos, very strong La Ninas. There is most definitely an effect on our weather, although it's not a constant effect. It'll vary from year to year and from event to event. ENSO neutral is much more problematical because its effects on the Pacific, on the southern oceans, on America, are going to be weaker compared to a strong event, and that means that the effects on us will be even weaker as well. James Atquill, who provides me with lots of analogues, charts, has done some analysis of ENSO neutral and La Nina winters. We're going to be examining that over the next few updates. We've got a lot of these updates to get through, so I'm not going to put everything into this first update. You have to come back perhaps next week or the week after, be in update 2 or 3. To see some of those analogues and see what the differing effects of ENSO neutral or La Nina winters are for us. But that's the broad situation in the equatorial Pacific, and likely to be so as we go in towards the winter. Now, elsewhere in the oceans, we've got lots of warmth. The Pacific Ocean is generally still in a very warm state. This has been the case for the last couple of years. And it still is the case. Actually, we've got all of this red up here in the northern part of the Pacific Ocean, and particularly up here in the northeast over towards Alaska and Canada. Those are above average sea surface temperature anomalies. And we've had that for the last couple of winters. Looks like we're still going to have it for this winter. It's very unusual, this, over such an extended period. This is normally quite a cold place, actually, up here. You normally have a lot of cold water. Haven't had that really since the winter of 2012, 2013. Looks like we're still going to have these warm temperature anomalies up here in the northeastern part of the Pacific Ocean for this winter. Quite when it's going to go cold. It will go cold eventually, because I say its default setup up there is normally quite cold with the ocean temperatures. When that's going to happen, we can't really say. But certainly for this winter, I think we're still going to have that warmth up there, which may fuel the jet stream across the United States and send it something like this. So it could bring a cold wind to the north and the east of the states. And of course, we know what the implications of that can be from winter of 2012, from winter of 2013, 2014, where it enhances the jet stream across the Atlantic and brings us very stormy conditions. Talking of the Atlantic, this is where we are with the Atlantic Ocean. Generally a lot warmer with the Atlantic this year compared to how we've been for the past couple of years. So you remember last year we talked about the cold blob quite a lot. Excuse me. Once again, I'm just going to have to stop, have a quick drink of water. Excuse me again. So you remember that last winter we talked a lot about the cold blob. This year the cold blob is much less extensive. Still got a little bit of below average sea surface temperature on this there in the central part of the Atlantic, but overall not a great deal. You have to say the Atlantic is a lot warmer, or the northern part of the Atlantic Ocean anyway, is a lot warmer compared to how it was last year, and compared to how it was the year before that, and possibly even the year before that as well. In fact, these were the sea surface temperature anomalies this time last year. This is from the 9th of the 9th of the 3rd, which of course is September the 3rd. And what we see is that a very cold Atlantic Ocean then in the north, of course, warmer towards the tropics a little bit, but generally a much colder northern Atlantic Ocean compared to what we've got at the moment. Now, there was a theory last year that a cold Atlantic could give us a cold winter. We discounted that because the evidence actually is that a cold North Atlantic tends to go along with a milder winter. So a warm Atlantic Ocean, when the Atlantic Ocean is in a warm AMO setup, that can actually increase the chance of colder winters for us. But it's not always the case. You have to get a tripole, which is a band of warm, cold and warm. And we haven't really got a tripole right now. What we want to be seeing happening through the course of the autumn is for these warm sea surface temperatures up here to be maintained. And of course we want to keep warm through the tropics. But here we want to see this area cooling down. So if we get a warm, cold and warm tripole, then we could be in business to start thinking about a negative NAO. But we didn't have it in May. I'm not expecting to see that emerge through the course of this autumn, but we will keep a close eye on it. Incidentally, that is the El Nino event that we had going on this time last year. Very strong El Nino event. As I say, we're expecting to stick around ENSO neutral. So this is the region 3.4 sea surface temperature anomaly forecast from CFS V2. This is where we are right now, around ENSO neutral. And you see the trend line, which is the black dashed line, generally sticking around neutral. This is neutral just here. Not a great deviation for into winter. This is January. So again, round ENSO neutral. A little bit of a warming process actually is forecast to take place to the end of the year, but only towards ENSO neutral. So we're not expecting El Nino, we're not expecting La Nina, we're just expecting to stick around ENSO neutral. We will be discussing the oceans much more over the coming few weeks. As I say, I've got a lot of very interesting analogues to look at in terms of ENSO neutral winters and La Nina winter. So we'll be looking at all those over the next 2 or 3 updates. Right, going on to something else, solar activity. So this is the latest on the sun, on the solar disk, on our side of the disk today from solarham.net. Officially, solar activity is moderate, and that's because we've got this large area of sunspots just here. Actually, there's not a huge amount of activity going on the surface of the sun. You see, there's not a great number of spots, but what we have got is quite a cluster of spots just here. This is one of the biggest clusters of spots, apparently, this year. So we may be seeing some auroras coming up over the next couple of days. And the main thing is that solar activity is increasing a little bit once again on the sun. So this was sent to us by James Ackrill. This is solar cycle 24, which is the current solar cycle in terms of monthly sunspot numbers. Now, if you watch Solar Sunday, but we did, I think about a month ago, or perhaps a couple of months ago, you know that we had this big crash in sunspot numbers. So this is where we was towards the start of the year, just here. You remember that we really dipped down in June, I think it was. Big crash took place from there to there. The last couple of months, so July and August, has actually seen a bit of a rebound in sunspot numbers. We've lifted up from that very low level that we went into in June. So we're back up towards trend. This is the trend line just here, this thick red line. We're back up towards trend. It was expected that we wouldn't maintain this level of sunspot numbers that we had down here in the immediate time frame, because it was well below trend. We probably won't be into this sort of level until perhaps around the summer of next year. So we have seen sunspot activity tick up. Remember, the reason we look at sunspots, and it's not really all that well understood, is that there's a relationship between weak solar activity, so small sunspot numbers and solar minimum, and an increased chance of blocking for Europe. So essentially, if you want a cold winter, what you're looking for is for the sun to be weak. Doesn't always work out every single year, of course. You do get some changes with that. So it's not a continuous process, but generally you're looking for weak sunspot numbers or weak solar activity. And the fact that we're ticking back up with the activity at the moment perhaps goes a little bit against the chance of blocking through the course of this winter. But of course we might get another crash. So we're going to be looking at these sunspot numbers, of course, over the next few weeks and couple of months. Now, you remember that last winter we spoke a lot about the current solar cycle, which is number 24, and the old solar cycle 12. There seemed to be a connection between these two solar cycles. Number 12 was back in the 1800s, 1878 to 1890. Cycle 24 is the current solar cycle that we are in. The winters, particularly, of these two solar cycles seem to be mirroring one another quite closely. So this chart from James Ackrill is showing us how solar cycles number 24 and number 12 have been aligning with one another over the past few years. So we can start here at the beginning of solar cycle 12 and 24, which is just here, and then we can go up to the maximums of both of these solar cycles, which is just here. Again, very close with the sunspot numbers. And then coming out of solar maximum down towards solar minimum, you can see I've been doing so really quite closely. This is where we are right now in terms of solar cycle number 24 and solar cycle 12. You see that solar cycle 12 did have a crash just on from where we are right now. Solar cycle 12 did have a big crash in sunspot numbers. So maybe we will go even lower with the sunspot numbers of solar cycle 24 compared to where we are right now. That's a bit speculative, but it's not impossible that we could do so. Like I say, the winters of these two solar cycles have been mirroring one another really quite closely. So these are the winter central England temperatures of the two solar cycles. We've got 1878, 1877, 1878 and 2007, 2008 just here. And they, at the start of both of these solar cycles, were mild winters. Then we get a cold winter there for winters number 2 and cold winters for number 3 of these two solar cycles, and again number 4 of these two solar cycles are both cold winters. The 5th winter of these two solar cycles goes mild. Then we get a split in the 6th winter in solar cycle 12 back in the 1800s. It's a mild winter. It's a cold winter in the 6th winter of solar cycle 24, which is 2012-2013. The 7th winter is mild for both of them. The 8th winter is generally just average for both solar cycles. But then we come to last winter, the 9th winter of these two solar cycles, and you see what's happened is that we've got a huge deviation now. We haven't continued the trend, or we didn't continue the trend last winter, because in solar cycle 12, which was the winter of 1885-1886, it was a cold winter, whereas last winter, which is 2015-2016, of course, very mild winter, but and exceptionally so in December of 2015. So quite clearly, last winter we broke apart the connection between the two solar cycles. Now what we're going to have to do is see whether this winter goes back towards the trend or whether we continue to deviate. The winter in solar cycle 12 was 1886-1887. This one just here, it was another cold winter. Be very interesting to see whether we continue or we go back to the trend, in which case we'll have a cold winter, or whether we'll continue to deviate and we'll have another mild winter for solar cycle 24, which will be just here, compared to its comparative winter in solar cycle 12. I hope you're able to follow this, quite complicated. But essentially, through most of these two solar cycles, we've been trending very similar with winters. Last winter, we got a big deviation. The question for this winter is whether we will continue to deviate or whether we'll go back to trend. If we do go back to trend, we will have a cold winter, because that winter that we're aligned with for this solar cycle, that winter in solar cycle 12, was a colder than average winter. James has sent through some reanalysis charts so we can see how the winter of 1886-1887 developed. Very interesting charts. I'll be showing you those in subsequent updates. One reason perhaps that we deviated last winter compared to its comparative winter in solar cycle 12, which was of course 1885-1886, is ENSO. We did have a weak El Nino back in 1885-1886. It's just here, but it's a fairly weak El Nino, and look how much stronger the El Nino of 2015-2016 was. So that could be one reason why we deviated with these two winters last time. Now what happened in the next winter, which is 1886-1887, is that it went down into a moderate La Nina. We're not going to get that this time. This is where we are right now. We're not going to go much lower than that. We may go to around here for winter of 2015-20, winter of 2016-2017, but we're not going to go down to this sort of level. So again, ENSO is going to be deviating this year compared to how it was in the winter of 1886-1887, and that could again split things perhaps. In terms of this chart, we might, we know the winter in the 1800s was a cold one. We might again do something different for our winter. We'll have to wait and see how that pans out. I've got a lot more information to come on that during the next few updates. So another thing that we look at is hurricane activity. This is the latest from Wikipedia page for the 2016 Atlantic hurricane season. And we can see that so far we've had 9 depressions this year. We've had 8 storms, 4 hurricanes, and 1 major hurricane, which is category 3 or above. The idea behind this is that if you get more hurricanes, the more hurricanes you get, what hurricanes are doing essentially is they're transporting heat from the tropics into the poles via the oceans. So if you get more heat being dumped in the pole via hurricanes, then later on into winter, it can translate back into risk of blocking. So once you've had a big hurricane season with a lot of heat being dumped into the North Pole, sometimes that translates back to an increased or enhanced risk of blocking. Over the past 2 or 3 years, we've had very quiet hurricane activity in the Atlantic. I'm expecting a bigger season this year. I think we'll have the biggest hurricane season since 2012. If we do get a lot of storms and hurricanes, that could be a precursor towards an increased chance of blocking. It's early days of hurricane season. We'll be monitoring that over the next few months. QBO next, quasi-biennial oscillation. Now, it's very rare that the weather does something totally and utterly unique, but the weather is doing something unique right now. So we should be in an easterly QBO. I'm not going to dwell on this too much at the moment. We'll discuss this later on in the autumn. We should be in an easterly QBO. In fact, we're in a westerly QBO. If we look at this chart just here, this grey area is showing us the westerly QBO. That shouldn't be there. We should be in white. We should be doing something like that. And again, something like that. And again, something like that. So what's happening with the QBO, quasi-biennial oscillation, is very rare. It's very unusual. It shouldn't be in this state, but it's in right now. And I'm absolutely unsure what the implications of the current QBO state are going to be, if anything. The QBO, when it's in its westerly phase, is enhancing the chance of zonality, because the QBO essentially is telling you that the westerlies in the northern hemisphere are strengthened. When the QBO is in its easterly phase, essentially it's telling you that you've got an increased, or you've got weaker zonal westerlies and an increased risk of blocked conditions. So essentially easterly QBOs are more likely to go with cold winters. It's not that straightforward, but that is very simple, is what should be happening. And what's going on with this ongoing westerly QBO that hasn't transformed to an easterly QBO is extremely rare. There's no year that's done this all the way back through the archive, and we can go right way back to 1950s with this, right back to 1953. There's no year that has done this. It's going to need a lot more analysis and research, and we may never really find out what the implications are, because it's an entirely unique situation, but I will talk more about it over the coming few weeks. Siberian snow cover and Arctic sea ice loss next. It's going on a little bit longer than I anticipated. We're up to 26 minutes. Sorry about that, but it's all very fascinating stuff, so I hope you're enjoying it. So first of all, seen with Siberian snow cover, not much going on there. We did have quite an increase in snow cover in the far northeastern corner of Russia a few days ago. A lot of that's melted. We've still got some little patches of snow up there, but it's very, very early days for this. This is going to become much more important in October, when this whole area, this huge mass of Siberia into Russia and then into Western Russia, eventually into Europe, that whole area is going to be filled up with snow, and how quickly that happens is going to be the key factor. Over the past couple of years, that's happened very quickly. And if you increase the snow cover across Siberia and Russia very quickly in October, it can help to give you a stronger Siberian high, which in some circumstances can increase our chance of a cold winter. Now, that hasn't come off over the past couple of years. And I think the reason for that is that the Atlantic has offset anything else. The Atlantic has been very set up for positive NAO, i.e. westerlies. We also last year, of course, had that El Nino going on, which was a super Nino event. So what's been happening across Russia and Siberia over the past couple of years hasn't really helped us a great deal, although for parts of America and Canada has given them, or did give them, strong conditions via cold conditions via the Siberian high. This year, because the Atlantic is in a much weaker phase, because ENSO is around neutral, things like this, what's going on across Russia, Siberia in October, and also, of course, we have to think about Atlantic hurricanes. All of that kind of thing could be more important this year, because we've not got the huge ocean drivers really offsetting everything else. So maybe this will be a little bit more important this year. We'll wait and see. having a big melt season again this year. So this is what's happening in the North Pole right now. We've got the yellow colours there, where we've got Arctic sea ice. The blue areas are where the ice has melted. Another big melt season is taking place. I'm going to show you this chart. This is a new chart for winter updates. This is Arctic sea ice extent. We go right way back to the 1970s with this. So I'm going to put where we are right now, first of all, which is this red line. So the thick grey line just here, that's the trend. You can see for 2016, we are well under the trend yet again, and I'll add all the other years in a moment, but right now we are well under trend. So if we have a look at the lowest year on record, which is 2012, when we went into the death spiral, that is this year, this green dash line. That's the lowest Arctic sea ice extent ever recorded. And now I'm going to add all the other years so we can see how 2016 compares. So we'll start with 1979, and what you're going to see very gradually is that more coloured lines appear. 1980, which is the biggest year where we retained ice, is that thick yellow line just there. 1981, 1982, 1983, get rid of that, sorry about that, 1984, 1985, 1986, 1987, there we are, they're gradually increasing all the years with the Arctic sea ice extent. Again, most of them are above the trend line at this point. 1990, however, is the first year to go under the trend. You notice that blue line just there, that's our first year that goes under trend. 1991 reverses that, as does 1992 and 1993, all very good years for retaining Arctic sea ice. 1994 was another very good year. This is around Pinatubo going off, of course, so that did have a cooling effect across the oceans, and I think that helped after quite a loss in 1990. That helped recover things in the early 1990s. 1995 next, and we're going back towards where we was in 1990, so we are beginning to trend down now. 1996 was a much better year. 1997, well, not too bad either. 1998 wasn't too bad. 1999 going a little bit lower now. Look, we've got a very pale blue line just going a little bit under anything that we've had before, and very gradually as we're going into the 2000s, you're going to see that more of these coloured lines start to dip lower and lower down. So we go for 2001, again, not too bad. 2002, however, this green line just here going a little bit lower once again. Remember, 2016, though, is down here. So these years in the early 2000s, well above where we are now in terms of retaining Arctic sea ice. 2003, not too bad. 2004, going down again towards 2002. And then 2005 is our lowest yet. That was a big melt season. At that point, we was quite surprised on the forums at how much ice we lost in 2005, but it gets worse. 2006, bit of a rebound. And then 2007, this was the year that really impacted Arctic sea ice a lot. This blue line, which crashed, we saw a crash in terms of Arctic sea ice in 2007. And that's about where we are now for 2016. I'm very much on a par with 2007. 2007 was exceptionally shocking when it happened. Hadn't seen anything like, of course, well under anything that had gone before all of these other years back to 1979. But you'll have gathered that 2012 was actually even worse. 2008, very similar to 2007. 2009, trying to get back towards the early and mid part of the 2000s. 2010, again, trying to get back. 2011, on a par with 2007. And then, of course, we get 2012, which is the death spiral year, catastrophic melting in the Arctic Circle in 2012, 2013, and then 2014. Not as bad as 2012, but more or less on a par with 2007, and then we finally finish up going through to 2015, And again, that's very much on a par with where we are now. So where we are right now in terms of Arctic sea ice extent and how much ice we've lost is really close to 2007. In fact, many of the years that have preceded 2007, except for 2012, which was the death spiral year. Now, it is possible, because we've got another couple of weeks to go, it is possible that we might bottom out close to 2012. So we might do something like this with this red line and go down towards that sort of level. I'm not expecting that. I think we'll continue around 2007, 2008, 2009, 2010 levels, but it isn't impossible that we might go down towards a death spiral, the death spiral of 2012. We'll have to wait and see over the next couple of weeks. We'll know quite soon. Remember, we look at Arctic sea ice extent and how much ice we lose, because it can eventually translate back to an increased chance of northern blocking in the winter if we lose a lot of ice. But the main thing is to monitor what the ice is doing, because I know a lot of people, and myself including this, get very concerned about what's going on in the North Pole in terms of how much ice we lose through the summer. So we will be able to see in the next couple of weeks how much ice we've lost. How long have I gone on for? 35 minutes. You want me to carry on a bit longer? I just wanted to throw this in. So this is percentage temperatures over the past few winters. So you'll notice that in 2013, 2014, we was above average for that winter. And then again, for 2014, 2015, above average temperatures. And then 2015, 2016, above average. So we've had three milder than average winters after a cold winter, which of course was 2012, 2013, just here. Now, the last time we had three milder or very mild winters in a row was back in the late 1990s. So 97, 98, 98, 99, and 99, 2000, which is this year just here, December 97 into 98, and then December 98 into January, February 99, and then December 1999 into January, February 2000. Those were three mild winters, and they were followed then by a cooler winter, not desperately cold, but 2000, 2001 had a cooler winter in December, January and February 2000, 2001. If we go further back than that to the late 1980s, we did it again. So we had the cold winter of 86, 87, which is just here, and then after that we get three very mild winters. So as we go through to December 1987 and then into January and February 1998, again, we're looking very mild. December 88 into January and February 89, very mild. December 89 into January and February 1990, very mild. So another trilogy of mild winters. Then the next winter, 1990 into 1991, that one is significantly colder. So we've had three mild winters in a row. When we did three mild winters in a row in the late 1990s, the fourth winter was cooler. When we did three mild winters in a row in the late 1980s, the fourth winter, which was 1990, 1991, was cold, properly cold. So it'd be very interesting to see whether this winter is a fourth milder than average winter in a row, or whether it reverts to something cooler. And of course, whether it's going to do that is what we're going to be analysing over the next few updates. So that's it for update 1. It's gone on a lot longer than I expected and anticipated, but we had a lot to discuss, set the scene. Hopefully the next few updates won't be as long as this. Hope you found it interesting and informative. This will be placed on the winter updates page, and there'll be a written version that goes with this as well on that winter updates page later on, just giving you a written version of everything we've discussed in the video as much as we can. Okay, that's it for now. My voice didn't hold out too bad, I don't think. So thanks very much for watching. As I say, hopefully the next few updates won't be quite as long as this one. Remember, all of these updates as we go along are going to build up a picture, patterns will emerge, and eventually it'll all be put together with long-range models, and we'll release a winter 2016-2017 forecast at the start of December. But at 38 minutes, nearly 39 minutes, That's all for now, and thanks for watching.